Find the quadratic equation which has roots 3 plus 2i and 2 minus I. So here we got complex roots. So alpha will be 3 plus 2i and beta is equal to 2 minus I. So a little note here. As the roots are not a conjugate pair, what I mean by conjugate pair, if that's 3 plus 2i, that would have to be 3 minus 2i. Or if that's 2 minus I, that would have to be 2 plus I. So as the roots are not a conjugate pair, the quadratic equation has complex coefficients. So the sum of the roots is exactly the same as before. Alpha plus beta, we do 3 plus 2i plus 2 minus I. So 3 plus 2 is 5. And then 2 minus I gives me plus I. So 2i minus I gives me plus I. So that's alpha plus beta is minus b over a. The product of the roots, alpha plus beta, will be 3 plus 2i times 2 minus I. So it's 3 minus 2i plus 2i times 2 minus I. 3 times 2 is 6 minus 3i plus 4i minus 2i squared. So that gives me 6 plus I minus 3i plus 4i, and then 2i squared. Well, I squared is minus 1, so minus 1 times 2 gives me plus 2. That gives me 8 plus I. That means that alpha plus beta is c over a. So letting a be equal to 1, because both of these are over 1, b is going to be minus this one, so we need to put brackets around all of it. And c is 8 plus I. Therefore, the required quadratic equation is going to be of the form az squared plus bz plus c is equal to 0. So a is 1, so it's going to be z squared. B is minus 5 plus I, so you need to put that in brackets, times z, and c is 8 plus I. So this has been finding a quadratic equation with complex roots which are not in conjugate pair. So I hope you've understood, and I thank you very much for watching.